Master Docker container images to build, deploy, and scale applications.
Hello, I'm the Code Architect. Today, we're diving into Docker fundamentals. We'll explore containers and images, the core of modern application deployment. My goal is to simplify these concepts, showing you how they revolutionize development workflows and streamline application management, making your life as a developer much easier. We'll cover their definitions, differences, and practical usage. Let's start with Docker images. Think of an image as a blueprint for your application. It's a read-only template that contains everything your application needs to run: code, runtime, system tools, libraries, and settings. Images ensure consistency across different environments, guaranteeing that your application behaves the same way regardless of where it's deployed. This is crucial for reliable deployments. Now let's talk about Docker containers. A container is a runnable instance of an image. It's a lightweight, isolated environment where your application runs. Containers virtualize the operating system, allowing multiple applications to run on the same machine without interfering with each other. This isolation enhances security and resource utilization, leading to more efficient infrastructure management. So what's the key difference? Images are the templates, while containers are the running instances. You can create multiple containers from a single image. It's like having a recipe, the image, and baking multiple cakes, the containers from it. Each cake is independent, but they all start from the same recipe. Understanding this distinction is fundamental to grasping Docker's power. Now let's understand how images and containers work together. We'll explore the container lifecycle from creation to termination. The lifecycle starts with creating a container from an image. Then we can start, stop, and restart the container as needed. Containers can also be paused and unpaused, allowing you to temporarily halt their execution without completely stopping them. Finally, we can remove them. I'll demonstrate these commands to create, run, stop, and delete the Docker container so you understand the container lifecycle. Now that we've covered basic Docker container management, let's discuss how Docker integrates into larger infrastructures. Imagine you're running multiple microservices in Docker containers. How do you manage traffic between them efficiently? That's where Envoy Proxy comes in. Envoy acts as a service mesh, intelligently routing requests, providing load balancing, and handling retries. It's like a smart traffic controller for your containers. But how do you monitor the health and performance of your Docker containers? Prometheus, a popular monitoring tool, excels at collecting metrics. Prometheus collects metrics, providing insights into resource usage and application behavior. Let's see how it helps Docker monitoring. Prometheus integrates seamlessly with Docker, scraping metrics from containers. Imagine having a central dashboard displaying CPU, memory, and network utilization for each container. These metrics are invaluable for identifying bottlenecks, optimizing resource allocation, and ensuring application stability. Real-time monitoring enables proactive intervention and prevents potential failures. Understanding container behavior is key. Now let's shift gears and discuss another crucial aspect of resilient Docker deployments: circuit breakers. These protect your system from cascading failures, ensuring high availability and fault tolerance. Scaling Docker deployments effectively is crucial for handling increased traffic. We can scale using Docker Compose or orchestrators like Kubernetes. Let's explore Docker Compose. Docker Compose simplifies multi-container application management. It allows defining and running multi-container Docker applications with a single command using a YAML file. Now, let's consider resource management in Docker. Docker allows you to limit the resources a container can use, preventing resource exhaustion. Think CPU and memory. In summary, we've uncovered the fundamentals of Docker containers and images. Understanding these concepts enables efficient application deployment and management. This knowledge can be used in many ways.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.